The circle cuts the y-axis at the points A and B. Find the distance AB. Verify that the point D, minus 5, minus 2, lies on the circle. Find the gradient of CD from the center to the point D. Hence, find an equation of the tangent to the circle at the point D. So here's the summary of all the question part then for B and C. And here's the information from the previous section. The circle cuts the y-axis of the points A and B, so when x is 0, find the distance AB. When x is 0, what does y equal? Well, when x is 0, let's put it in here. So part B then, x equals 0 gives, and then we can see where it cuts the y-axis, can't we? So we get y squared. This is 0, this is 0, so we get y squared minus 2y minus 3. So that tells us then that y equals minus b, which is 2, plus or minus the square root of b squared. Minus 2 squared is 4. Minus 4 times a times c. That's a minus. 4 times 3 is 12. So it does factorize, doesn't it? Which is what we wanted. So let's go to factorizing it now. Now that I can see what factors are what. Y and y, 3 and 1. I should have seen this before, of course. A minus and a plus. So that tells us that y is equal to minus 1 and also 3. Let's just double check that. Y squared minus 3 plus 1y is minus 2y, and then we get minus 3 here as well. So there's our points on the y-axis where the circle cuts it. So the distance AB, so dist AB is the distance between these two y values, which is 4 units. Okay, verify D minus 5 minus 2 lies on the circle, and it's better to use this form here for part C. So part C now, here. Okay, so let's use the original form here. So we're going to put in minus 5 here. I'll put it over here and then move it down. So we get minus 5 plus 3 squared for that one. And the y value, minus 2 minus 1 plus minus 2 minus 1 squared. So let's see what we get then. Do we get 13? So we get minus 5 minus 3. This is equal to minus 2 squared is 4. Minus 3 squared is 9. 9 and 4 make 13. So, okay, the point does lie on the circle. So that point does lie in the circle. Find the gradient of C to D. So the center, C has coordinates, remember, minus 3 and 1. I've cleaned it from here and here. And D has coordinates minus 5, minus 2, doesn't it? So gradient CD is equal to C to D. The increase in y is 1 to minus 2 is minus 3, divided by the increase in x, which is minus 3 to minus 5, which is minus 2. So that works out as 3 over 2. So that's the gradient CD. So that was from the center to the point D. The tangent at D will be perpendicular to this gradient. So gradient of tangent now then. This is part 3. So gradient of tangent is equal to, and it will be minus 2/3, won't it? Because when you multiply these two numbers, you get a product of minus 1. So this implies then equation is y minus the y value at D, which is minus 2, so it's plus 2, is equal to the gradient, minus 2/3, x minus the x value, which is minus 5. So let's just tidy this up. Y is equal to minus 2/3 x, and then this will be minus 10/3, won't it, when we expand the bracket. Move the minus 2 over, and I'm going to write that as minus 6/3. So it's equal to minus 2/3 x minus 16/3. So we can write it in this form, if we wish. Okay.